Welcome to Daikin web-based training. In this course, we will learn about piping restrictions, fitting types, pipe size selection and calculation of additional refrigerant charge amount, all of which are needed when designing refrigerant piping for the VRV3 heat pump system. The following are what we will be learning in this course. 1. Names of refrigerant pipe fittings. 2. Piping restrictions. 3. Pipe selection. First, let's take a look at the names of the various parts of the refrigerant pipe network that must be understood when selecting pipes. Here, we will use the piping diagram for a VRV system. In the case of a multi-outdoor unit system, an outdoor unit connection piping kit is used to manifold the refrigerant pipe connected from one outdoor unit to other outdoor units. In order to connect indoor units, a refrigerant branch fitting kit, known as a RefNet joint, is used to connect the main trunk line to the branch lines. A RefNet header is another type of refrigerant branch fitting kit that is used to connect one refrigerant pipe to 4 or 8. The nearest refrigerant pipe fitting from the outdoor unit is called the first branch, and the piping between the outdoor unit connection piping kit and the first branch is referred to as the main pipe. We will explain the piping selection criteria that is shown on this detail. These drawings can be located on page 53 in publication EDUS 391004N, VRV3 Installation Manual. The area within the red box details the piping rules as they pertain to VRV piping installation. This slide shows the selection table used when selecting the branch fittings and refrigerant network piping, as well as the method used for determining the refrigerant charge. These charts can be located on page 54 and 55. Let's start with an explanation of the restrictions shown in the red box. The maximum length is the length from the first outdoor unit connection piping kit to the farthest indoor unit. The actual length must be no longer than 540 feet, and the equivalent length no longer than 620 feet. However, if the equivalent length exceeds 295 feet, the main pipe must be increased one size in accordance with the instructions. Now, let's go over the difference between the actual and equivalent lengths, as well as the piping method used if the equivalent length exceeds 295 feet. The actual length refers to the length of the refrigerant piping actually used. The equivalent length refers to the piping length corrected by converting the friction losses that have occurred at the fittings into a prescribed length and adding it to the actual length. Although the correction factor or equivalent length for the fittings differs depending on the pipe size, with VRV calculations it is always calculated assuming each fitting at 1.5 feet to simplify the calculation. In the case of the piping shown on the slide, for example, the actual length is 300 feet. There are 4 fittings. Therefore, a total of 6 feet is added to the actual length of 300 feet, making the equivalent length 306 feet. The size of the main pipes on the liquid and gas piping must be increased according to the pipe size adjustment table, if the equivalent piping length between the outdoor and indoor units exceeds 295 feet. The longer the piping, the lower the capacity of the air conditioner. Therefore, the pipe size needs to be increased in order to compensate for this. Let's now go into an explanation on the difference between when the pipe size is increased and not increased. Let's again take the cooling operation of an RXYQ216 model as an example to understand this. In this example, the equivalent length of the main pipe is 200 feet, and the equivalent length of the piping after the first branch is 100 feet. A correction factor is needed to account for the increased pipe size. The formula used to obtain the total equivalent length is the equivalent length of the main pipe multiplied by the capacity correction factor plus the equivalent length of the piping after the first branch. The capacity correction factor is 0.5 when the size of the main pipe is increased, and 1.0 when it is not increased. Accordingly, the total equivalent length is calculated as 200 feet with size increase and 300 feet without size increase. We will next look at these lengths using the graph that illustrates the difference in cooling capacity presented on the next slide. This graph shows the differences in cooling capacity when the RxYQ216PTJU or PYDN outdoor unit is used. It compares the actual line length applying the correction factor after increasing pipe size to omitting the correction factor and not increasing the pipe size. The vertical axis represents the level difference, and the horizontal axis indicates the equivalent length of refrigerant piping. In this example, we assume that the indoor units are installed below the outdoor unit, and there is a level difference of 100 feet between the indoor and outdoor units. Let's now look at the previously obtained total equivalent piping lengths of 200 feet and 300 feet on this graph. The capacity decrease rate is 89% when the pipe size is increased, but it is 84% when it is not increased. This suggests a 5% difference in capacity. As the capacity index 216 suggests, the capacity of this unit is 18 ton, or 216,000 BTU per hour. Therefore, this 5% would be equivalent to 10,800 BTU per hour of power, creating a difference of approximately 1 ton. Next, let's take a look at the piping length after the first branch. This is the length from the first branch to the farthest indoor unit. According to the piping restrictions, this length must not exceed 130 feet, but this can be extended to 295 feet as long as the 4 prescribed conditions are met. Now, let's look at these 4 conditions. The first condition is that the size of both the liquid and gas piping must be increased 1 size between the first branch and the last branch for the indoor unit installed farther than 130 feet from the first branch. The second condition is that the total piping length does not exceed 3,280 feet, when it is calculated by twice the piping length of the section where the pipe size is increased. The third condition is that the actual length from each indoor unit to its nearest branch fitting does not exceed 130 feet. The fourth condition is that the difference between the actual piping length from the outdoor unit to the nearest indoor unit and that to the farthest indoor unit does not exceed 130 feet. When all of these 4 conditions are met, the distance of the actual piping length after the first branch to the farthest indoor unit can be changed to up to 295 feet. The piping length from the first outdoor unit connection piping kit to the farthest outdoor unit must not exceed 33 feet. Let's now look at the restriction on the total piping length. The total piping length refers to the total of the lengths of pipe from the first outdoor unit connection piping kit to all of the indoor units, and this must not exceed 3,280 feet. This calculation must include all correction factors and equivalent lengths discussed previously. Next are the restrictions on the level difference. The level difference between indoor and outdoor units must not exceed 295 feet. However, this differs depending on the outdoor unit model, as well as whether the outdoor units are installed higher than the indoor units. Let's take a look at these differences. If the outdoor unit is installed below the indoor units, the level difference between the indoor and outdoor units must not exceed 295 feet. Meanwhile, if the outdoor unit is installed above the indoor units, the level difference must not exceed 164 feet when it is a standard model. When refitted, this level difference can be changed to between 164 and 295 feet. In any case, the size of main pipe may need to be increased to the next larger size depending on the equivalent piping length. In a multi-outdoor unit system, the level difference between the outdoor units must not exceed 16 feet. And the level difference between the indoor units, highest and lowest, must not exceed 49 feet. Let's now go over the restrictions on the connection. When a RefNet header is used, piping cannot be branched again after the RefNet header. In a multi-outdoor unit system, the installation sequence of the outdoor units, looking from the indoor unit side, must be from largest to smallest in terms of capacity. As shown in this table, there are also limitations on the number of indoor units that can be connected. This is based on the model number of the outdoor unit. For example, an RxYQ72 unit could only be connected to 12 indoor fan coils. An RxYQ192 manifolded system can be connected to up to 33 indoor fan coils, and an RXYQ 360 manifolded system can connect up to 62. Using the RXYQ 72 as an example, let's now look at how to determine the branch fitting types, refrigerant pipe sizes, and amount of additional refrigerant charge. These charts and tables show the guidelines for selecting the refrigerant branch fitting type, refrigerant pipe size, and amount of additional refrigerant charge. They can be found in the publication noted on the screen. We will take a look at the areas enclosed in the red boxes in order to determine these items. When a RefNet fitting is used for the first branch, confirm the appropriate fitting kit on this table based on the capacity of the outdoor unit. In this case, the outdoor unit capacity is a 72 type, so we will select this RefNet joint. Never determine the first branch fitting size based on the total capacity of the indoor units. Now, let's look at how to determine the fitting B. The appropriate branch fitting type is determined based on the total capacity of the indoor units connected downstream of the fitting in question. In this case, 24 and 36 type indoor units are connected downstream. This gives us a total indoor unit capacity of 60. On this table, 60 falls under the less than 72 category, so we will select this fitting kit. Let's now look at how to determine the pipe size. We use the outdoor unit capacity in order to determine the appropriate pipe size for section A, which is referred to as the main. In this case, the unit is an RXYQ 72, a 6-ton system. Based on this table, we will select a 3/4 inch pipe for the gas piping and a 3/8 inch pipe for the liquid piping. Never determine the size of the main pipe based on the total capacity of the indoor units. Let's now determine the pipe size for section B. We use the total capacity of the indoor units connected downstream of branch fitting B in order to determine the appropriate pipe size. In this case, the total capacity of the indoor units is 60. According to this table, the gas pipe size is 3/4 inches and the liquid pipe size is 3/8 inches. If the pipe size turns out to exceed that of the main pipe, select the same size as the main pipe. Let's now determine the pipe size for sections C, D, and E. We use the capacity of the indoor unit connected to the respective piping in order to determine the pipe size. An 18,000 BTU indoor unit is connected to section C. Therefore, based on this table, we will select a 1/2 inch pipe for gas piping and a 1/4 inch pipe for liquid piping. Similarly, a 24,000 BTU indoor unit is connected to section D and a 36,000 BTU unit to section E. This table indicates that the pipe size is the same for 24 and 36 types. Therefore, we will select a 5/8 inch pipe for the gas piping and a 3/8 inch pipe for the liquid piping. Next, let's look at how to determine the amount of additional refrigerant charge. We use the true pipe sizes and actual piping lengths of the liquid refrigerant piping as opposed to the equivalent lengths in order to determine the amount of additional refrigerant charge. First, let's find out the liquid piping length for each pipe size. In this case, the total piping length of the 3/8 inch pipe is 180 feet, and that of the 1/4 inch pipe is 50 feet. Next, we will multiply the lengths previously found for each pipe size by the indicated factor or multiplier. According to this chart, the multiplier is 0.040 pounds per foot for the 3/8 inch pipe and 0.015 pounds per foot for the 1/4 inch pipe. When the total piping length for each pipe size is multiplied by the respective multiplier, it results in 7.2 pounds for the 3/8 inch pipe and 0.75 pounds for the 1/4 inch pipe. Next, according to Table A, the additional refrigerant charge amount for the outdoor unit RXYQ 72 is 1.1 pounds. Then, according to Table B, the refrigerant amount for exceeding the connection capacity of the indoor unit is determined. Comparing connection capacity of the outdoor unit and indoor units, the outdoor unit is 72,000 BTU, and the indoor units are 18, 24, and 36,000 BTUs. The total connection capacity of the indoor units is 78,000 BTU. 78 divided by 72 is 1.0833. 1.0833 means 108.33%. This is the total connectivity. Therefore, 1.1 pounds is selected from the 100% to 120% section on Table B. These figures are added, and the total is rounded off to the first decimal place, deriving an additional refrigerant charge amount of 10.2 pounds. Therefore, the required branch fittings, refrigerant piping sizes, and additional refrigerant charge amount would be as shown here for the RXYQ72 example used.